Okay, here's the first part that you're going to be doing. Turning the packet first off to number 12. This is the wrong number. That's supposed to be 8. Okay. Now you're solving exponent functions here, solving for x. Now this isn't 5 times x, okay? It's 5 to the x power. If it's times x, the x would be here right beside the 5. So what you're going to do is make an upside down v, because that stands for a power. I know for sure that that's 5 to the x power. So then what I do is I parenthesize the power and my base. First I have to solve for the power, which incidentally in this problem will be the answer to the equation, the solution. Now make sure there's nothing going on outside of the power. There's not. Now there's 2 ways you approach this. Here's the most logical way. Figure out how many 5s it takes to multiply to 625. 2, that's 125, and that's 625, okay, because that equals 625. So how many factors of 5 is that? It took 4. So x is 4, and that's my answer to the equation. Now, in the next problem, 25 to the power of 2x equals 125. Okay, so again, I need to solve for x, but the problem is x is in a power. Okay, so if I need to solve for the power, so I put 2x equals. So the first thing I will be doing, and you're wondering what's for over here? Well, that's if this doesn't work. I have a fallback plan. So 25, that's got to get to 125. That's your base. Multiply it to 125. Well, that's too high to be 125. So that plan didn't work. Abort mission there. So now what you do instead, you have to use your change of base formula, which is when I take 2 logarithms and divide them. Now, whatever the base is, 25, that goes on the bottom. It's not just always the smaller number on the bottom out of these two, okay? If that was 125 and that was 25, I'd be putting 125 on the bottom, but 25 goes here. So 125, so I take log 125 divided by log 25. I got 1.5, okay? So the power is equal to 1.5. So now to find the x, I divide both sides of the equation by 2, and that's 0.75. Okay, next problem. 3 to the power of x equals 36. Solving for x. Okay, so again I parenthesize the base and its exponent. Okay, nothing, there's no operations outside of the power. These two things together make the power. Okay, that's the base, that's the exponent. So I need to solve for the exponent because that's where the x is at. And by the way, cross out 36. I want to change that. I want you to put 1 over 9. Okay. So how do you multiply 3's to get a product of 1/9? Well, I know how to get 9. I just don't know how to get 1/9. Well, we can just do 9 if we put a negative right there. And that allows me to reciprocate that to 9. So multiply 3's out to 9, and that's it. So it's 2. So x is equal to negative 2. Okay, my next problem, 7 to the power of x minus 3 equals 25. So again, the x is a power with a base. Okay, nothing outside. 7 times 7. There's no way you can multiply 7's to hit a product of 25. So what I do is I use my change of base formula, COB. So 7 on the bottom, 25 on the top. You always put the base of the exponent on the bottom. So log 25 divided by log 7, 1.65. So x minus 3 equals 1.65. Now to solve for the x, we got to add 3. So that's 4.65. Okay, next problem. 5 to the power of x plus 3 equals 12. So I'm solving for x is the power, so x equals. Now before I can worry about I have to know what I'm multiplying 5 out to. With that plus 3 I don't know, so I need to minus 3 from each side of the equation. That's 9, and it's 5 to the x power. Now I got to multiply 5's out to hit 9. That's impossible. Okay, so that doesn't work. So then we do the COB, the change of base formula. Okay, me putting 5 on the bottom, 9 on the top. So I take log 9 divided by log 5. I got 1.37. Okay, next problem. First off, there's the x. 2 times 10 to the power of 2x plus 1 equals 30. So I got to first solve for my whole power, 2x plus 1. I got to find out what that even equals. Now I don't know what to multiply 10 to until I divide by 2. And one thing you can't do, you can't take 2 times 10 and call it 20 to the 2x plus 1 power. Okay? That's not right. You don't understand the property of the powers. To multiply these, the only way I would be able to multiply them is if they were both had the same power. Okay, that's to the 2x plus 1 power. That's to the power of 1. So the powers are different. Okay, so multiplying here you can't do. So what you need to do then is the opposite of multiply, which is divide both sides of our equation by 2. I have 15. So you have 10 to the power of 2x plus 1. Okay, so I multiplied 10's out to get to 15, which I can't do. Okay, if you think about it logically, 10 times another 10's 100. So you find out what your exponent equals using your log over log. So 10 on the bottom, 15 on the top. The base on the bottom, the product on top. Okay, I get 1.18. So I minus 1, that's going to be 0.18. Then I divide by 2, and that's going to be 0.09. Okay, next one. 2 to the power. There's my power, there's the exponent. Okay. So we have to divide both sides of the equation by 5, and that's 100. Now the power has been isolated. Okay. Now I can solve for the exponent. So multiplying 3's out to 100. 3, 9, 27, 81. Over 100, so that way it doesn't work. So 3 on bottom, 100 on the top. .19. So that's what the power is equal to. Now to just get to the x, you just got to add 3, divide by 2, 3.60. Okay. Okay, next one. So there's my power, there's the base. Okay. Got to know what the power equals. I don't know that with the times 10. So if I untimes by 10, which means divide, that's 100, 4 to the power of x. Remember, it's not 25. 4 to the 25th power is not 20, not 100. 4 to the 25th power is like a ginormous answer, so it's not 25. So 4, 16, 64. That's over 100 right there, so we use the log divided by the log. Okay. So 4 on bottom, 100 on top. So we take log 100 divided by log 4, 3.32. Okay, now if you want to pause the video and do 1 through 8, you can. You don't want to work past 8 until I do these. Okay, first off, I made a lot of mistakes here. You need to cross out that 243, and that needs to become a 9. Okay. Now you're solving for x, but the problem is you have a logarithm. You want to get rid of this logarithm and put it in an exponent type equation. So you have to know the base of the log. It's 10 if you don't have a number there. Next thing you need to do is see if the log's isolated. So from the L to the end of the parentheses, I don't have anything, okay? That doesn't count. It's on the other side. So now we can convert it to an exponent notation. Put what's in parentheses, we put right here. Now on the other side, we take the base 10 and raise it to the power that's over here, -2. Now I'm just going to use my caret button. I'm going to show you why it ends up as this. 10 to the power of -2 is 0.01. Now I'm going to tell you why that's 0.01. Because if you have 10 to the -2nd, it's 1 over, and then I can make it positive. So that's 1 over 100. 1 divided by 100, 0.01. This is the decimal equivalence to that fraction. .002. Okay, next problem. Base 10. The log's isolated, so I rewrite it. 4x, and then over here we're going to have 10 to the first power. The base, and then that's the exponent. A log's always equal to an exponent. So 4x equals 10 divided by 4. That's 2.5. Okay, next one. Yeah, the x isn't going to end up being the power on these, so that's why I don't have to do the log over log. Usually, okay, I'm getting rid of the log. I can use. Okay, then here. Isolated 5x, and that's 4 to the third, that's 64. 4 times 4 times 4, divided by 5, and that's 12.8. Okay, now here I keep telling you to block that off, because right now you have a multiplier of 3 in front of the log. Well, you can, if you divide by 3, divide 9 by 3, that's 3. Now I can convert it into a notation. So x, and it would be base 3 to the power of 3. So 3 times 3 is 27. So that's the solution. I also wrote a bunch of the wrong numbers. Like every single one of these I wrote wrong. That's 2. We're going to call that 3. 3. And let's call that a 1. Okay. That's my fault. Okay, now with 2 logarithms, first we use our properties to condense them, okay? So write log base 10, make 1 parentheses, and you put x divided by 3. Now, because it's minus, you want to express it as division then when you're condensing it. Okay, now get it out of, you're good outside, you don't have anything in front here. So now you can rewrite it into an exponent notation. So the x divided by 3 is equal to base 10 to the power of 2. 10 to the power of 2 is 100. What number divided by 3 is 100? Well, how about I multiply and figure out? That would be 300. Okay, next problem. Those are base 10s, but now you need a base, but you want to condense it so it's in just 1. So we're going to take 3x to the second power. Minus means I will divide by 3. Okay, now we need to simplify that, okay? 3x to the second divided by 3. Wouldn't the 3's just cancel? And I have x to the second. 3x to the second divided by 3 is x to the second. 10 to the third power, okay? Thousand, okay? Find the square root of 1,000. and you can just do it like this. You don't have to write it in simplified form. 31.62, and whenever we square root, it could be a positive or a negative. Okay. Next up, base 10s on those logs. I go 6x to the second divided by x. If that was plus, I would times it by x, but it's divided by 6x to the second divided by x. The 6 stays, okay, and that just becomes 6x, okay. So I have 6x, that goes here, 10 to the third power. That's 1,000. $166.6 repeating. Okay, base 10s. Then 8x to the second minus means divide by 4x. Okay, you should know what that divides into. 8 divided by 4 is 2. X squared divided by x is x, so it's 2x. Okay, so 2x equals 10 to the first. 10 to the first is 10. And here I get a divide because it's 2 times x. Okay, pause the video, finish the packet, and then the other one. Okay, now you're solving exponent equation for x, but the problem is x is on both sides and it's a power. So I really can't do the figure out how many of these, because there's exponents on both sides. So when there's exponents with variables on both sides, there's a plan A and a plan B. Okay, here's plan A. I'm going to rewrite this equation so that this number and this number, the bases in the equation, are the same. So they're equivalent. Here's how I do that. I take my larger base and write equals. Then I take my smaller base and see if I can multiply nothing but 4s to get 64. Okay, I can do that because that's 64 right there. So that equals 4 to the third power. So I replace 64 with 4 to the third. Okay, these are equal, so we replace one with the other. So 4 to the third. And then we make a parentheses and put the 3x that was there originally. That doesn't just go away. After I replace that with 4 to the third, I put up 3x in parentheses. Now this side stays the same then. Now here's what's the point of that. Now the 4's you can cancel. Okay? And we know that 2x minus 5 is equal to 3 times 3x, which is 9x. Now solve for x, you just need to subtract 2x from both sides. So that's 7x, then divide by 7. That's a decimal, I'm just going to leave it -5/7. Okay, next problem. Power. Again, we want the bases to wind up the same. Here's plan A. Take your 49 and rewrite it using base 7. 1, 2, that's 49, so equals 7 to the second. So I replace this with this. And over here, 7 to the power 3x plus 4. 7's go bye-bye. And now I just have a simple equation. So I got 3x plus 4 equals 2 times 2x plus 1. So I take 2 times the quantity. You got to take 2 times both of them. It's 4x plus 2 minus your 3x minus your 3x minus your 2 minus your 2, and then your answer is 2. Okay, now I'm not a fan I'm doing this next problem, but we're not a fan of the one. By the way, here's what this says. It's 1/6. And then outside is 11 minus 1x. Okay. Now I don't like this 1, 6. I would rather have it be 6. Well, I can make it 6 if I make the exponent opposite. So the opposite of 11 is negative, the opposite of minus 1 is plus 1. Now I'm to where I want to be. So remember, that's negative 11 plus 1x. So 36, 1, 2. So that's 6 to the second. And over here you got 6. And then negative 11 plus 1x. You can now cancel out your 6's. So 2 times 5x, 2 times 2. It's going to be 10x plus 4. And over here you have the same thing. Okay, so I subtract 1x. That takes me to 9x. Minus 4. That takes me to negative 13. Divide by 9. That's going to be negative 13 over 9. If it's a decimal, just leave it in fraction form. You can divide it if you want, just round the decimal. Now what are we going to, we're going to do another problem, and you're going to see that that plan A doesn't work, but you have a fallback. Okay, it's not a fun fallback like the change of base, but that's what we have. Okay, we need these to be the same. Well, if I try to pull the same stunt I did last time, 27 is the higher base. That's too high. That doesn't work, okay? So we're going to rewrite both the bases. Now, here's how you accomplish that. You use what's called prime factorize. A prime factor is just a number times itself. We're going to write these both as a product of prime factors. So you know 9, what comes to your mind? What times what's 9? You can't be 1 and 9 though. It has to be, you can't do a 1 when you're doing a factor tree. Be 3 and 3. Okay, and those are prime factors because it's just 3 and 1. So 9 is 3 to the second. Now 27, what times what's 27? Doesn't have to be the same thing times itself, okay? Well, it's 3 times 9. I mean, if you look at my multiplication charts in front, you'll see it's 3 times 9. 3 is prime. 9 can go into 3 and 3. Remember, you're not allowed to do a 1. The only thing you can do with this 3 is 1 and 3. I said you can't do a 1. So that's 3 to the third. Now, we're going to come here, replace the 27 with 3 to the third. And the 9 is going to be replaced with 3 to the second. So 4x minus 1, and then 3x plus 8. 3's can be canceled. 3 times 4x minus 1, that's going to be 12x minus 3. 2 times the quantity 3x plus 8 would be 6x plus 16. So I minus 6x. And then I add a 3. Divide by 6. You could put 19 over 6. You could also put 3.16 repeating. I don't care. Okay.